B, when we multiplied, we got two terms. We got a real plus an imaginary. A real plus an imaginary. On C, we just got a real answer. Why? What made the imaginary part cancel? Logan?
Multiplied by conjugate.
We multiplied by the conjugate. A conjugate is the exact same thing, but with a different sign on the imaginary part. So that's a trick we're going to be using today. Anytime we need an I to cancel out, we can multiply by the conjugate. Okay, so let's look at this. With a complex number, I told you standard form is A plus BI, the real plus the imaginary. That means you cannot have an I in your denominator. So if I had a problem like this one, I have to get the I off the bottom. Now in this case, it's fairly simple to do because my denominator is only I. So all I really have to do is multiply top and bottom by I. As long as you do it on top and bottom, you're okay. So the top will give me a 3I. The bottom will give me I squared. So that's 3I divided by negative 1, which is negative 3I. We wrote it in standard form. What's the real part of that number? 0. There is no real part, and the imaginary is your negative 3. Okay, B is a little bit different. Don't write this down, but if you just multiply this one by I on top and bottom, you would have to distribute. So you would get 3I plus 2I squared on the top. The bottom, you would get 5I minus I squared. Did that make my I disappear? No, it just moved it to the other term. So on this one, just multiplying by I isn't going to cut it. So what do we multiply by? The conjugate, 5 plus I. So on the conjugate, the real part doesn't change. The imaginary part changes sign.
Fully fold, you just do FL.
On the bottom, yeah.
Alright.
So on the top, if I distribute this out, 3 times 5 would be 15, plus 3I, plus 10I, plus 2I squared. On the bottom, if you distribute, you get 25 plus 5I minus 5I minus I squared. Now, like Dalton just said, on the bottom, if you recognize since they're conjugates, do you really have to FOIL the whole thing? No, because in conjugates, the outside and inside terms always cancel. So if you just multiply the first and last because you recognize those would drop, that's okay. So on the top, 2I squared would be negative 2 times, or plus 15 would give me a 13 plus 13I. On the bottom, 25 minus I squared, so it would be 25 plus 1, so 26. We can reduce this. Now, technically, this is still not a standard form because it's one big fraction. So what we are going to do is go ahead and separate this, and we'll put each one over the denominator, because in standard form you separate the real and the imaginary, and then you can reduce 13 over 26 is 1/2 plus 1/2 I, or I over 2. So I would like for you in these fractions, go ahead and separate it at the end so you have A plus BI, real plus the imaginary. Any questions for me on that? I want you guys to try some. So here are your problems. So about half of you multiplied by I on top and bottom, which gave you 5I over 9I squared. But what's 9I squared? Negative 9, so you got negative 5 over 9I. The other half of you multiplied by 9I on top and bottom. you got 45I over 81I squared. 81I squared is negative 81, but what does 45 over 81 reduce to?
15I over
15 over 27, but then you divide both by 3. So does it matter? No. First was, yeah, if you only have one term, all you really have to multiply by is the I. But if you did multiply by the 9, it reduces later on, you get the same answer. So it doesn't matter. Now,
Sorry, does it matter if the I is on the outside or if
If you
I have
put
it on the bottom?
it doesn't matter. B. This one has 2 terms on the bottom. So can I just multiply by I there? No. This is the one, if it's more than one term, you have to multiply by the conjugate. Now, is it the conjugate of the top or the conjugate of the bottom? The bottom. So conjugate is the same thing, you only change the middle sign. So if I start distributing, I get 16 minus 12I plus 9I squared. On the bottom, you might have recognized their conjugates. You only have to do first and last. If you multiply them all out, it doesn't take much longer and you still see that they cancel, so it's not a big deal. So on the top, I get 16 minus 24I,
Wait, how did you get them to cancel?
because these are conjugates, so they're opposite signs. So negative 12I and positive 12I.
Oh, you were doing the bottom.
Yeah, sorry.
I was looking at top.
On the top, they don't. You just have to add them. So then on the bottom, you get 16, negative 9I squared would turn into positive 9. So we get 7 minus 24I over 25. Is that okay for my final answer? That's technically not standard form yet. We need to just break it apart for the standard form. So 7 over 25 over minus 24 over 25I.
So if you don't do that, I'm gonna tell you.
I'd probably take off a half because in the directions I'll say write it in standard form.
I'll forget to do that, so.
But it's your directions.
I'll still forget to do it.
Okay. Any questions there? Alright, in this chapter, we're talking a lot about quadratics, and we are going to see our eyes appearing in expressions like this. Do you guys know when you would come up with something like that? Do you remember from algebra 2? Okay. It's something that you might see in the quadratic formula. But let's just work on simplifying this right now. We would have to work with that radical. So, yes, because of the negative, you are going to have an I. Now let's see, can 128 break down otherwise into a perfect square? Hmm? 36? 64 works. Okay, so the square root of 64 is 8. Because of the negative, I pulled out an I, and we have a radical 2 over 4. Divide everything by 4. So you could separate it first if you wanted, or you could just go straight into dividing by 4. It doesn't matter. So you get negative 2 plus 2I radical 2.
Yeah, I remember that. We did that in geometry too.
Mm-hmm. Okay, here's your problem. Are we okay with simplifying these expressions? Yes.
How do you get the 2 plus 2?
I divided 10 divided by 5 for both of them.
Are we looking for simplifying the negative, or are we looking for the greatest?
Yeah, you need to find the biggest perfect square that goes into it. So your perfect squares are like 4, 9, 16, 25. Okay. The last thing I want to talk about give you I squared, what does that turn into?
-1.
What if I gave you I to the third?
-1I.
Right, that means I to the third is the same as I squared times I, right? I squared is -1, so you get negative I. If I gave you I to the fourth,
Positive I. What do you mean?
that means I squared times I squared.
So,
I squared is -1 times -1 is 1.
I mean 1.
What if I gave you I to the fifth? If you think about how many, that's like I squared times I squared times I, right? I squared is -1 times -1 times I, and you get I. Negative times negative makes positive. When I give you powers of I,
Should be able to do it in the calculator.
they simplify. The only answers you're going to get are positive and negative, 1 or I. If I gave you I to the sixth, that's like I squared 3 times. If you take -1 and multiply it 3 times, what do you get? -1. I'm back up to the top of the list, and we're just going to keep repeating these things. Now,
There's no way to do it.
there is a shorter way, because if I gave you I to the 56th power, you wouldn't want to write this down and figure it out. But you notice the trick is I'm trying to simplify these into groups of I squared, because every time we get 2 I's, it turns into a -1. So let's say I gave you I to the 15th power. You could write out 15 I's and start multiplying them. Or we could rewrite this using I squared. So, how many groups of 2 can go into 15? 7. 2 times 7 is 14. That is accounted for 14 of my I's, so we have 1 left. Would you guys agree? Okay. I squared is -1. So this is -1 to the 7th power times I. If you take a negative to an odd power, is it positive or negative? Negative. So this is -1 times I, so my final answer is just -I. So rewrite it using I squared. So if I said I to the 33rd power, that would be I squared to the 16th. That accounts for 32 of them, so we have 1 left over.
So that'd be
Right. And -1 to the 16th would be a positive 1 times I is just I.
Is that on the math exam? Yeah. Is that so that's part of the criteria? So, I don't know the division on that, I didn't know that was that.
I think I put some on there. Alright, if I said I to the 22nd, that's I squared. 22 divided by 2 is 11. None left over this time. -1 to the 11th. You guys know how we're getting these?
Yep.
Okay. You ready for one that you have to think a little more?
Yeah. After, I'll say it's like 1,000 numbers.
I to the -12.
Oh, see, I know.
What does a negative exponent do? Change floors. So this is just
So I would plus that would.
1 over I to the 12th. Now can we break down this I to the 12th now? Absolutely. That's I squared to the 6th. So I get 1 over -1 to the 6th is 1, and I get 1 for my answer. have quite a bit of time left. You're probably going to be able to get all or almost all of your Math Excel done. That is due tomorrow, so we're moving on to the next section tomorrow.